Hello, John here again, and this is tutorial 34, and the reason why we're doing tutorial 24 in between tutorial 33, which is the Neptune Lander development, is because we are going to use some of the code that was supplied by the excellent book RetroGameDev, the C64 edition, by Derek Morris. And so what I thought I would do is do a video about some of the coding that's in there that we're going to use in the Neptune developer. Now, if you don't know what RetroGameDev is, here it is. This is the front and back cover of the book. It's an excellent book written by Derek Morris that doesn't go into the coding aspect of C6502 on the C64. It goes into the methodology of building a game on the C64. And so what he does, he provides on each chapter the code that goes with that, and you read the chapter and how and what it's all about and the methodology behind it, and then you go into the code and find out exactly what he's done. And it's a really, really good book. You can get it on Amazon and all good book places. If you're into the C64 and you want to program machine code, it's one of those must-have books. And we are going to use the sample code that is provided for the shooter, which is this game up here, because you get 2 games with this book, and we're going to use some of the libraries out of there. Now, Derek has got quite a lot of standardization in his code, and so what I'm going to do is just quickly go through that standardization. Now, all his macros are standardized around a particular format, and this format is that the name is the assembly file name, the macro name, and the parameter format. And to give you an example of that, this is actually one of his macros. So libscreen is the library, so it's a library for the screen. The macro name is draw text, so we're going to be drawing text on the screen, and its parameters are going to be an address, an address, an address, and a value. Now, admittedly, we don't know what that address, that address, and that address, and that value are for, but that's where we go into the code and find the macro and see exactly what it's for, because in the macro itself, Derek has put some very useful comments that explain how that macro works. So, the green is the assembly name or the file name that's in the project, the blue is the macro name, and the orange is the parameter format. And like I say, A is for a 16-bit address and V is for an 8-bit value. So in terms of how the code works, I've just taken out one of his macros, which is a screen macro, and it's a debug 8-bit, and it's taking 2 values and an address. And this macro basically allows you to put a value on the screen when you're debugging the system, and it's very clever. So this is the typical macro code, and what he's doing is explaining what the 3 parameters are. So we are taking 2 values and an address. So value number 1 is the X position, and so we're assuming that that's the X position where you want to put the number. Parameter number 2 is the Y position, so the Y position of where you want to place the number. And parameter 3 is the number low byte pointer, because it's an address. So this parameter is going to be pointing to the address of a 16-bit number, an 8-bit number, sorry. So it's the low byte of that. and then he's got the code that does it. So he's in this particular case, he's loading white, setting the text on the for the screen, putting a space, and then he's clearing out 4 spaces, and then he's setting the row, he's setting the column, putting the cursor on the screen, and then printing out the decimal number. And as you can see, because the high byte is set to 0, he's only going to be printing out a number between 0 and 255. Right, so that's an example of the macros. So what macros has he got? Well, first, the ones that what I've done is I'm going to explain the ones that we're going to deal with the Neptune Lander. Is we got the sprite library, and this is the first page of macros in that sprite library. So using his format, which is consistent all the way through, except for one thing, and then I think he forgot, but we'll talk about that when we get there. So we're in the sprite library, and this macro is did collide with sprite, and we're sending in an address. This one is to enable a sprite, and so we're passing an address and a value. This one is the animation playing, and we're sending in an address. Multicolor enable, and we're going to send in 2 address points. Multicolor enable, and we're sending an address point and a value. Playing animation, and you can see there's quite a lot of parameters on that, and I think this is where we set up the animation. Set color and we're setting the sprite color using an address and a value, setting the sprite color using an address and address. Then we've got setting the frame, and that is the setting the frame of the animation using 2 addresses, or setting the frame using an address and a value. Setting the multicolors using 2 values. Setting the position of the sprite using 4 addresses. Setting the position of a sprite using a value and 3 addresses. Setting the priority of a sprite using an address and a value, and stopping the animation using a address. Now the reason why this is not coloured, but it's in the sprite library, is this is a routine that updates the sprite. So when you want the sprite updated, you would call this routine, and this routine is mainly for the animation part of it. But if you're not using animation, you still use this routine, because you want to standardize all your sprite modifications. And so this is an actual routine that's in that library, and we will use that in a bit. The other library that we're going to be using is the math library, and these are give me an absolute value. So if you've got a value between, if you pass in a 2's complement value between -255, -128 and +127, it will return back a positive number. So if you've got -10, it will return back +10. If you've got 10, it will return back 10. So that makes a number that's both positive and negative into a positive number. This is to add an 8-bit value using 3 addresses, add an 8-bit value using 2 addresses and values, add a 16-bit value, add another 16-bit value, but the parameter list is different. This one is to find the minimum of 2 numbers. So we're finding the minimum of what's in that address and this value, and what it does is whichever is the minimum gets passed through. This one is what is the maximum of these 2 numbers, what is the minimum of this 16-bit number, what is the maximum of this 16-bit number. Oh, I've got the colours wrong there. Oh well. Subtract an 8-bit number, subtract another 8-bit number, but we're using a value instead of an address. Subtract a 16-bit number using this parameter list, and subtract another 16-bit using, and we've got an extra value. So we'll be using this math library, and we'll probably be adding some to the math library, because we want to be able to do more complicated maths and stuff like that, and we'll get to that when we go to back to tutorial 34, because we need to add some more routines to this math library. But that's what these libraries are for. The other one is libscreen, and this is, I haven't gone into it to so much detail, but this is the one I used as a demonstration. It's to display a 16-bit, well in this particular case it's not 16-bit, it's a 8-bit value on the screen at coordinates x and y, and it's got some drawing text, draw a decimal, get a character. Not sure what this pixel to character is because I haven't looked at it. This one is to scroll the screen left using the hardware scrolling, and in fact my presentation's a bit all over the place because there's a lot more screen. Let's sort this out. Right, that should go there. Sort that out. Right, back to maths. I wondered where they were. So the other library we're going to be using is the input library. So we're going to use this library to take the input from you, the user. So thrust, left and right. I mean, this is just for the joystick, but this input will expand so we can take keyboard inputs as well. And then we've got another routine inside this library that does the update of the input. So once you've taken the input, it does some things, and we'll have a look at that in other videos. Now, so we've done the screen, but we're not going to we will use this screen library when we start putting up high scores and stuff like that, but I'm not going to go into it at the moment because we're not going to use it right now. So we've got scroll X right, reset the scrolling, scroll using a value, an address, set 38 column mode, 40 column mode, and there's a few others in here. There's wait, which we're going to use this as well. We're going to use this macro at the bottom, wait. And then we've got a library dedicated to the sound. So we've got the process wave, process attack and decay, sustain release, what's the set frequencies, pulses, delays. Right, so that is just a basic overview of some of the macros that David Morris has put in his code. So what we're going to do is going to look at the sprite one. That's the one that we're going to be using right now for the Neptune Lander tutorial 33. And so what he's done is saying he's set to maximum of 8 sprites, and because there's only 8 sprites in hardware sprites in the 64, but I suppose this code can be modified to use multiplexing technology that allows you to have more than 8 sprites. But we're not going to look at that because, to be honest, the Neptune Lander only needs 1, 2, 3, 4, 5, 6 sprites total, and some of those sprites are on the same one because some of them are toggle sprites. But anyway, so we're setting up the sprite array. So we've got a sprite array that says is the animation active, what's the start frame of the what's the current frame of the animation, and what's the end frame. This is the stop frame array, what the speed of each of the animation of the sprites are, what's the delay, and looping. Then we've got some bytes that when you set the current sprite, what's the animation of the current sprite, what's the end and the end frame of the current sprite. And then we've got the sprite masking, because when you, as I've done before in the Vic chip explanation, is the sprites are governed by 1 byte, and each bit inside that byte is for a specific sprite. So we've got a masking array to give us the corresponding bit for that sprite. So that's sprite 1, 2, 3, 4, 5, 6, 7 and 8. Right? And then we come to the macros. So the first one was did did collide with a sprite, and we're putting in an address value, and the address value is the address value of the sprite number. And so what it does, it loads the sprite number from that address, then loads the masking bit for that sprite, and then ANDs it with SPSPL. Right, and if you want to know what that is, you have to grab hold of the Mapping C64 book, because what Derek's done is he's kept to the naming convention of this book. So if we go to the Vic chip, which is here, yeah, right on cue, look. So this is foreground collision, so we're looking for sprite to sprite collision. There we go. So sprite to sprite collision, which is reference DO1E, and there you go, SPS PCL. So that's the name. And what he's done is it's basically saying, did my sprite that I'm testing collide with another sprite? Doesn't tell you which other sprite, but did I collide with another sprite? And then what happens is you will end up with either that sprite bit set or not set, and so you would test the bit configuration that comes out of it. Sprite enable, so we're sending in the sprite number via a memory address, and we're setting whether it's enabled or disabled by a value. And so first we're loading in the sprite number, then we're loading in the sprite mask number, and then we're loading whether it is enabled or not. And because we're loading in, it sets the 0 flag, so we can test for whether it's disabled, because enable or disable is like true or false. Enable will be -1 true, which is not 0, as false is 0, so that's what he's testing. So branch if equal, because it's we're setting it to false, to disabled, and then because we've loaded in the sprite masking bit, we are then notting it, so we're enabling all the other bits bar the bit that we want, and then ANDing it against SPENA, and we go back to here. So we should be able to see the enable bit, which is up here somewhere. It's more closer to the top of, so that's index 17. Here we go. So there's the XYs and the most significant bit. Scroll. Raster. There we go. SPENA. That's the one, isn't it? SPENA. And so this is the sprite enable byte. And so we're ANDing it with what's already there, and then storing it back minus the bit that we want to disable. If we want to enable it, we are taking our masking and ORing it with that enable byte, and then storing it back, and then jumping out. This one's a simple one. Is the sprite animation playing? And basically we load the sprite animation active array for that sprite number that's in an address, and then return back, that returns back the bit, the true or false. Returns back true or false. Setting the multicolor using two addresses, so the address number is going to be an address, and the enable and disable is going to be in an address. Basically doing the same thing as enabling, sprite enabling, but this is the multicolor one. But he's also got another one which is setting enable or disable by a value rather than, so we're sending in a value rather than an address that contains the value. Play animation, well, this is basically setting up the animation for the sprite. So if you've got a sprite that's going to go through many different frames while you're playing, and we're going to use this for the explosion, because the explosion has many many sprites to it that make it run through, and so we're going to be setting that up. And this is how you set it up. You take which is the sprite you want to animate, and you're sending in the address of that sprite number. What's the start frame? What's the end frame? What's the speed you want the animation to work at, and whether it loops. Yeah, and then that sets up the animation. So when you do the routine that I said, which was the lib sprite update routine, that update routine looks at your animation configuration for that sprite and changes and does the animation. The next one is setting the sprite color, and we can set the sprite. Of course, we're setting the sprite from an address value, but we can send in a value to set the color, or we can set. There's another one which sets and it tells that the color is in an address point. Setting the frame of the sprite, so we're sending in the sprite color and the animation index, and that sorts out the animation, and we can do it by address or value. Set the multicolor by 2 values. So this is setting up the multicolors. So color 1 and color 2, and we're using 2 values. Setting the setting the sprite position, and we're going to pass in 4 address memory locations. So we're setting, the first one is to set the sprite number, X, I bit and low byte, and the Y position. And what it does down here for the high byte, it loads the mask and sets the most significant X bit and stuff like that for the X bit, but it also does the clearing out of it. So what it does is we load it and we clear it out and then set it. Yeah. So, but we could, if we wanted to do, is, you know, we can test whether we need to clear it out. But we're not gonna do that for the moment, because this is Derek's. But we could make it more efficient by saying, you know, what's the value at the moment? Do we need to clear it out? But this blanks it out before resetting it. And we've got one where we're setting the sprite number as a value, but everything else is an address. Setting the sprite priority. Well, the sprite priority is whether the sprite is in front of the background, which is where you type all your text, or behind it, and that's what it means by setting the sprite background. And we can stop the animation. So if the animation's on a loop and you want to stop it, you can use this macro to stop the animation. And then this is the library that does all the updates. So it's going to loop through all the sprites. It's going to find out if the sprite's been animated. If it's not, then it goes to if it is, then it goes to animation. If it's not, it skips the whole lot and comes down here, and then does the next sprite and the next sprite. And then when it's done all the sprites, it says, you know, jump to the looper, which is here, and goes round again. But if it is finished and got all the sprites, then it comes out and finishes. So this is basically just to update the sprite information of your sprite collection. So if there's any been animated, we use this. All clever stuff. So that's the sprite. And then on the maths, we've got various math routines. So adding 8-bit, so we're taking address of the first number and where the low byte of where we're going to put it. Same with the value. So we're putting in the first number address, what's the value, and this is where we're going to put it. And same with the 16-bit, 3 pairs, address of the first, value and address of the second. And I think that's because if you add two, I'm not too sure why it's the value one, because I would have expected, you know, that you could have a 16-bit. There should be another macro where it's address, store it in address. So I'm not too sure what that one is, what that one is used for. Maybe it's for using for when they're working out the X position for the sprite. Maybe, that's probably what. Yeah, that's probably what it is. 16-bit one, you're doing an address. Number 1 is an address base value. Number 2 is a value base value, and store it in this address. Minimum value, taking 2 numbers, and we're replacing number 1 with the end result. Same with max, we're taking 2 numbers, and number 1 is the end result. Do it with the 16-bit one, and the number 1 16-bit address has the ending result. Same with the max. And then we've got the subtractions, which is the same as the additions. So address 1, address 2, address 3 where it ends up. Same with all the rest of them, and they're all the same configuration as add. And we're going to be adding some more to these. We may add a multiplier, we may add a divider if we need to this library, and increase the math library as we go. And then the last one is the input. Now we're running into 26 minutes, so I'll quickly run over this. So we've got some constants, we've got some bytes that we're going to be using. So the last frame, what this frame is and the difference. Have we got a delay, and whether we I'm not sure when it says reverse logic. So we're going to look at the game port and it with the button mask that we want. So if we're testing for left, and it'll return back the button mask if we're using it or not. Yeah. So it'll return back one of these. And then this is whether the button has been pressed. Yeah. And there's press and hold. There's double hit. So I think that's what that blip is. Did we double hit it? And it works all the whether we've held it or just pressed it or double pressed it, because I think in Derek Noyce's platformer you've got that double press scenario, so he's using that. And then we've got the update that does all the updates for us. Alright, so they're the 3 macro routines that we're going to use, and hopefully that's give you a basic understanding of those 3 libraries we're going to use in the Neptune Lander tutorial. So I hope that's been informative and interesting. Get the book. If you are serious about doing this, get the book. It's well worth. I think it was £11, I think it was at the time. It's well worth it, and Derek is writing it at the time of recording. Is writing book number 2, which is, as he's called it, chapter 2 of this series. So, if you like this video, press that like button. If you didn't like it, fine, press the dislike button. Always leave a comment. I try and answer all of them. And if you're not a patron of this channel, please consider becoming one, because the money that comes in helps me to pay for this channel. Until the next time, I'll see you then. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.